Okay, even though we're only really going to be talking about arithmetic sequences in series today, it's important to understand what that is compared to a geometric sequence. Okay, so it depends on how you get from term to term. If you analyze this, the way we're getting from term to term is by adding 3. I didn't leave myself much space here. But 2 plus 3 is 5. 5 plus 3 is 8, and so forth, right? If you look at this one, it doesn't work. You can think, okay, I'm adding 4, but then 6 plus 4 isn't 18, right? It doesn't work with adding or subtracting. So we're going to have to find a different pattern here. And we're multiplying by 3, right, to get from term to term here. 2 times 3 is 6, 6 times 3 is 18, and so forth, okay? So we can say that an arithmetic sequence has a common difference. Okay, so it has a common difference. So you can take any term and subtract the previous term. So 5 minus 2 is 3, right? 8 minus 5 is 3. 11 minus 8 is 3. That's why it's called a difference, because if you take any term, subtract the previous term, you get the same thing out every time, okay? This has a common ratio when we're looking at geometric sequences. So if you take any term and divide by the previous term, 6 divided by 2 is 3, 18 divided by 2 is 3, and so forth, right? Those ones have a common ratio. And we'll get back to the geometric sequences in series later, but I wanted you to understand what an arithmetic sequence or series is first, okay? All right, so we're going to start with what I call the arithmetic specific term formula. This is a way to find a specific term in an arithmetic sequence, in any arithmetic sequence or series, actually. So here is the formula. You're going to take, that would be the first term, whatever the first term is, okay? And we're going to add d, which is the difference, the common difference, okay? And then we're going to multiply that by n minus 1, okay? So just to go through the different pieces here and make sure we all understand, that's the first term. It's the value of the first term, okay, is what we're going to put in there. D is the common difference. And n is going to be the term number. Okay, so let's try this out here, okay? So I'm supposed to find the 71st term in this. Now, yeah, I could build this out to 71 terms, and I always get some students that try to do that, but I'm on the tests, I'm going to make it not worth your while to do that. I want you to be able to use the formula. So, you know, if I asked you for the 800th term, you wouldn't want to build this out to 800 terms. And I do get people who try to do that, and you probably will lose your place along the way if you do. It's going to be much easier when you're looking for something far down the line to use this formula, okay? So what I'm going to do here, I'm going to take the first term, which, hey, I can see that is 20, right? Okay, then I'm looking for the difference. So now I got to analyze this and thinking, how am I getting from term to term? Some people are going to say, oh, it's a difference of 6. But remember, we're subtracting 6 to get from term to term. Okay, so you can have a difference that is negative. Or if you take any term and subtract the previous term, 2 minus 8 would be negative 6. So be careful there, okay? So my difference is negative 6, okay? And then n is my term number. So here, since I'm looking for the 71st term, I'm going to plug in 71 there for n. And then I got it down to this, okay? And then it's just a little PEMDAS from there, okay? So I'm going to work on that parentheses first. Okay, and then I'll do the multiplication. And then finally the subtraction, and I'm going to get negative 400. And you can kind of spot check these. If you look at this, we're going to get into the negatives with the next term, right? So we should be pretty far down the road with the negatives. Yeah, I mean, you can't tell exactly, but you can at least tell if you made a mistake with the term. And you can kind of think, that makes sense that 71 terms down the road here, we'd be at negative 400, okay? All right, so let's try another here. You can pause the video and try it out if you like. I'm going to use that formula at the top of the page, so I'll leave that on screen. Okay, so I'm looking for a sub 38. So I'm going to take the value of the first term, which I can see is negative 10. Okay, then I'm going to take the difference. I didn't leave myself space again, but I'm going to be adding 6. And I can see it works all the way down the line, so my difference here is positive 6. Okay, and then my n is 38. Okay, so 38 minus 1 is 37. Then I'll multiply here. That's 222, and then finally puts me out at 212. Kind of makes sense. I know I'm going to be in the positives there. A couple hundred sounds pretty good for the 38th term. Okay, if you kind of imagine. All right. All right, so now we're going to write a rule for the nth term. And a rule is, it's a formula. It's a term building formula, okay? So what I'm going to do is I'm going to use this same formula I had up here, okay? So I'm thinking, all right, I'm going to be using a sub n equals a sub 1 plus the difference times n minus 1, okay? So I'm going to build a little formula then that I can use to find the value of any term. So I'm going to need the first term, which, hey, I can see that is 3. Okay, I'm going to need the difference, which here I can see I'm adding 5, right, to get from term to term. Okay, and this is a rule. I've just plugged in really the difference and the first term. Now, usually you'd want to simplify this, so let's go ahead and simplify it. We can distribute the 5. Okay, and then we can combine the 3 and the negative 5. So then a sub n is going to equal 5n minus 2. Okay? And that will allow me to build any term. And we can try it out. If I plug in a 1 for n, that should give me the first term. Well, 5 minus 2 is 3. If we plug in a 2 for n, that should give me the second term. That would be 10 minus 2. Yep, it works. Works for all of these, and it will work for any term in this sequence, in this arithmetic sequence. Okay, so writing a rule is just plugging in your known information to write a formula, a term building formula. Okay. All right, on to the next page. We're going to look at so we had the arithmetic specific term formula that we were just dealing with. Now we're going to look at the arithmetic sum formula, okay? And so here it is. So this is for the sum of an arithmetic series. And here's what it's going to look like. I don't know why I keep going back and forth between my style of A's, but it doesn't really matter. Okay, so n is going to be the number of terms, as always. Or it can be the term number if it's, if it's this. But yeah, it's, for a series, it's going to be the number of terms. So if I had s sub 77, that means I would be finding the sum of first 77 terms, right? So that's the number of terms, okay? A sub 1 is going to be my first term, right? A sub n is going to be the last term. Okay, so let's say we're looking for the sum of the first 77. Well, this would be a sub 77 up here, okay? So if you look at what we've got inside of the parentheses, this is really the average of the first and last terms, right? So that's how I remember this. It's the number of terms times the average of the first and the last terms. That's how I remember it. Okay, so let's try this out. Okay, we're asked to evaluate this, and you have to know that we've got an arithmetic sum, because I haven't really taught you how to recognize that this is arithmetic, but all the ones I'm going to show you today are arithmetic. Really, so it should say evaluate the arithmetic series for all of these, just so we know. Okay, so you could build out the whole thing. There would be 22 terms, but let's try out this formula. Okay, so I'm going to find the sum of the first 22 terms. Okay, the number of terms is going to be 22. Then I've got the fraction. Okay, so I'm going to average the first and last terms. Well, I don't know what the first and last terms are, so I'm going to have to find them. okay, I'm going to build the first term. So the first term I'd get by plugging in 1 for k. Okay, and then I'm going to have all the stuff in the middle, which I don't really care about right now. I only need the first and the last term. So then I'm thinking, well, the last term I'd get by plugging in 22 for k, because you would plug in all of the integers from 1 to 22, right? So if I can just find those two terms, then I'll be in business and I can save myself a lot of time. So I'm thinking, okay, this would be 7 plus a bunch of stuff in the middle, and then I've got 3 plus 88. That is going to give me 91. Okay, so there's my first and last terms, and now I've got something to plug into those places, right? So now I can just do the math a lot quicker than expanding the whole thing. So let's see. I'm going to have 98 over 2, and that's going to be 22 times 49, which comes out to 1078. Okay, let's try another. All right, so this is going to be the sum of the first 15 terms. So there's 15 terms, and then I'm going to take the average of the first and the last term. So I've got to build this first term. That's how I get my first term, by plugging in a 1. And then the last term I'd get by plugging in 15. Okay, so 15 minus 20 would be 30. Let's start with 30, got all the other stuff. And then let's see, that's going to come out to negative 250. Okay, so my first term's 30, last term is negative 250. Okay, so I'll start simplifying the fraction part. And there we go, negative 1650. Okay, and it makes sense if you think about it. If I'm ending up negative 250, most of these terms are going to be negative if I've got an arithmetic sequence here, right? Okay. All right, so let's try another. So same formula. This is still an arithmetic series. So I'm going to find S sub 16. So I know my term number is going to be 16. Okay. I need to find the first term, which, hey, it's right here, right? That's A sub 1. So I need to find that, and I need to average that with the last term. Okay. So I've got to find this piece. So I've got two different options. One would be to build out the whole sequence, all 16 terms, which actually wouldn't take me too long here. But, you know, it wouldn't make sense if we've got a really large sequence that it's you know, the sum of the first 300. I wouldn't want to do that. So here's how we can also handle this. We can find a specific term, because I know this is an arithmetic series, right? So I can think about the related arithmetic sequence. And I can use the specific term formula, right? Because this piece is A sub n, and I've got a formula for A sub n over here, right? So in this case, the last term would be the 16th term. Okay, I know the value of the first term is 12. Okay, and looking at this, I can tell that the difference is going to be negative 5. Okay, so I got negative 5 here, and then 16 minus 1, my term number, minus 1. Okay, and then I can simplify this. And negative 63 should be the 16th term there, so that's going to be the last term in that series. Okay, and then I can just simplify this. So you kind of got to do a little problem within a problem when this is written in this format to find these. You got to figure out what the last term is by using the specific term formula. Okay, let's see. That fraction, if you simplify it, it's going to come out to negative 25.5. And then negative 408. Okay.